This is take two of me trying to teach you reactions of alcohols. And in this lecture, excuse my throat, in this lecture, we will cover how the reactions of alcohols really take place. Like, we are not going to dive into specific reactions, only the basic mechanisms and what are the basic type of reactions we can expect from alcohols. And whenever we look at the mechanism which includes an alcohol, what kind of shenanigans can we expect? So let's start with the basics. Let's observe the structure of an alcohol. There is R, there is O, there is H. This O has lone pairs. This basic stuff you need to know. And this O is strong enough to cause both of the bonds to become slightly polarized. Like this, electrons come towards the O bond. They tend to go towards O, which causes a slight positive charge on both of its substituents, its friends. Now what happens is this positive charge makes the alkyl group really susceptible to nucleophilic attack. But there is one small problem here. The OH minus group is a terrible leaving group, like it cannot sustain by itself. So, what we need to do, we need to convert this into a good leaving group. And how do we do that? I'll come to that later. Okay, so now I want to tell you some basic properties within the alcohol itself. The hydrogen atom is weakly acidic, as I said. The oxygen atom is nucleophilic and weakly basic. Like you look at these lone pairs, it makes that pretty nucleophilic, and it also makes it pretty basic as well. Now, the excuse my throat, guys. So now I guess we can begin how to make the OH minus group a good leaving group. The very first straightforward way is that you simply add an H plus. Now you see this guy is nucleophilic. It likes positive charge. And voila, there's positive charge right in front of me. So what am I going to do? I am going to snatch it. But my friends, as you all know, greed comes with consequences. And this extra bond caused oxygen to get a positive charge. Dun, dun, dun. This is a problem. Why is this a problem, you may ask? Oxygen, a very electronegative atom, the second most electronegative atom in the entire periodic table, it has a positive charge. Such blasphemy cannot occur in my kingdom, and hence the oxygen now has to make a choice. Let go of this H, or this alkyl. Well, it just accepted an H. Imagine you are sitting in your home and suddenly a guest comes and sits at your sofa, and then you suddenly kick that guest out. How will you feel? Right? So, what happens is oxygen just betrays its first friend. Now, yeah, things happen. This will start the gym arc of the alkyl group. But what happens is this entire chain of H, H, and O, this departs as water, and this plus charge basically it just gets here to the alkyl group. So this makes a carbocation plus water. But see, this what I told you, this is what happens in case of SN1 reactions. The water leaves first. This may or may not happen depending on structure of the alkyl. We are not going to dive that deeply into SN1 and SN2 right now. I just wanted to tell you how to make the OH minus group a good leaving group. Now you know that H2O is a good leaving group. How do you know that? Well, a good leaving group is stable. Because if it is stable while being detached from its connected entity, then only it is a good leaving group. Like, say you are doing a job and you are not stable without the job, you don't have enough money to be stable, so you will have to continue doing the job even if you're even if you really want to detach yourself, because in the end you just want to be stable. But say you have like crores in your bank account and you are working a 10,000 rupee job, you will say, "Hut, I don't need this job," and just go away because you are happy with your own money, you are stable. So, how do I know H2 is stable? Well, you drink it every day, bruh. So, enough about H2O. Let's talk about the alkyl group now. So in an SN1 reaction, what happens is that this guy just leaves and another nucleophile comes. It comes here, forms a bond, new relationship forms. That is the SN1 thing. And what happens in SN2 thing? This is water. This guy comes. It attacks from the backside. Walden inversion takes place, and this guy just leaves. And again, RX is formed. This is how the reactions happen. Now, this was the first way to convert the OH minus group into a good leaving group. But there are more ways. What are more ways? Now, first, I need you to introduce to this guy. Let's say this is Z. Now, what is it? No, it's not zirconium. I need you to understand this is sulfur dioxide. Okay, but in sulfur dioxide, the sulfur atom is left with two more lone pairs. So one of those lone pairs is used to form a bond to an organic compound, and the other one is used to just bond itself to another group, which can influence its properties. Now, whenever this in itself, this entire entity is a really good leaving group because of the resonance structures. And well, whenever there is an extra oxygen on this side, which usually happens in organic reactions, this become an insanely good leaving group because there are three identical resonance structures. Let's see an example of OTS. What is OTS, you might ask? OTS is basically this entire thing when Z is a toluene. As you can see, not only does it have resonance stability from its three equivalent oxygen atoms, it also has resonance stability from the phenyl group, which makes it an insanely good leaving group. And the same effect can be seen when Z is equal to CF3, also when Z is equal to, say, nitrophenol. And why does this happen? Because the positive charge on the sulfur atom gets delocalized, and that makes it a really good leaving group overall. Let's see an example of how this thing takes place. Say you have this compound, not this is cyclohexane ring, and there's an OH here, and there's a methyl group over here, and I want to convert it into this. Now, water, as you know, water sometimes departs by itself and it usually promotes SN1. But here you can see the inversion takes place. So, how do I promote SN2? OH minus is not a good leaving group. So, what can I do here is I can react it with TSCl. Now, if you still don't know what TS is, I just showed you. This is TS when Z is equal to toluene. Okay. So, once you react it with TSCl, what happens is the compound gets repeated, but instead of the acidic H atom that was there before, we have a newly formed OTS. And if I just told you this is a good leaving group, this OTS group, as you see, this bond was never broken. So currently there is no change in the stereochemistry of the molecule. Now what happens, I just send in my secret agent and it attacks the compound from the top side, and that means it will kick the leaving group out of here, chal foot, and since it attacked from the top side, it will get attached on top of this. So this creates our desired product. Now, as you see, this is just a test lecture. We did not dive too deep into mechanisms. I just wanted to tell you what kind of mechanisms you can expect from reactions where alcohols are involved. And while this does not cover everything that is there in alcohols, I am sure that it will be of great help. And the entire concept of making the OH minus group into a good living group has been stuck and hammered into your brain. Keep in mind, I am also a student, so this is nothing but basically a revision exercise for myself as well. So if you are not benefiting from this video, you will likely not benefit from the upcoming videos as well. But if you happen to benefit, please let me know in the comments, and if you don't, please let me know in the comments that where I can improve. I have no teaching experience, as you can tell. Thank you for watching and have a nice day.